Okay, geology class, for this one, I'm going to introduce three questions. There are three different parts to well, there's three different questions here. I've got question three divided up into parts 3A, part 1 and 2, 3B, and 3C. Okay, so for this one, we're going to go to Jordan, Minnesota, right here, so a little south and west of the cities. And if we zoom in on it, there's the town of Jordan. And we'll back out a little bit more here. And you can see the river flowing through there. The Minnesota River, boom, down here, up through Jordan, and connects then with the Mississippi. Okay, so we zoom in on Jordan. We're going to be looking at a particular spot on the Minnesota. Sorry, I keep messing those up. On the Minnesota, just north of Jordan. And there's a gauging station here that keeps track of something called stage, river stage. You've heard of flood stage. Stage is simply the height of a river, the height of the surface of a river. The more water it is, the more water that is in it, the higher that the stage would be. You can actually see this gauging station. If I get it to the right spot here, we'll put the cursor right here. And I got to spin it around a bit here. There's the Minnesota River, and there is the gauging station right there. Okay, so that's keeping track of the height of the Minnesota River. And this is July of 2019. That was, oh, come on. Obviously very wet at this time because there's quite a bit of water in the river. You can see the shrubbery on the sides flooded. Okay, so what we're going to be doing here is what insurance companies do to determine your insurance rates. They're going to be, and it's what people do to predict disasters and all sorts of things like that. So we're going to be looking at question 3A, part 1. And in that, you're going to calculate the percent probability of the recurrence of a flood. Okay, and you're going to use actual data for that. You're going to fill out this table right here. And so this is the percent probability of recurrence. Okay, and what would the stage be? The height of the river above the normal measuring point, which at that spot I showed you was 690 feet above sea level. So stage is the height of the river above that. And so you can see water levels, maximum stages of various heights. And what's the biggest one here? There's a 33.5, 34.37. Maybe that's the biggest one in 1965 because it says magnitude number 1. Okay, so the percent probability of recurrence for that should be fairly low since it was a high flood. Whereas if you take the lowest high water mark, that's 8 feet 37 inches, or 8.37 feet, gosh, above flood stage. That has a magnitude of 67, okay? So now your lab manual goes through a pretty good description of what you want to do. Basically, you want to determine the percent probability for all of these floods right here in part 1. And then in part 2, you're going to want to plot that data on this map right here. So you determine, let's see if I can get this down a little lower. Okay, you've determined percent probability right here, and here is stage right here. So from this previous diagram, which you've just filled out, you've got stage and height of the river, and you've got percent probability. So then you simply plot those data. Be very precise with this, folks. Really, really careful plotting the data. You're going to have to interpolate between some of these lines. And then you're going to draw a best fit line. Okay, a straight line has to be straight. That comes as close to all the points as you can. Okay, that's going to be the first part. So if you do a good job here, the rest of this will fall into place pretty good. Okay. So hopefully you've gotten that done. Now, if you've done a good job, question 3B is going to be straightforward, reading it right off that graph. And so it talks about in the spring of 2001, the maximum stage of 33.11 feet was achieved. And it wants you to estimate the recurrence interval, I think it was after recurrence interval, for a flood of that magnitude. Okay, so you've got a stage, you take it across to the line, and then down to your recurrence interval. And so you've got, again, you've got stage, take it across to your line, and then down to your recurrence interval. I was actually pointing at the screen like you could see that. Sorry. And you will determine the recurrence interval. How frequently will a flood of that magnitude reoccur? If it's a high frequency of recurrence and you try to build your house there, you're going to have picking high insurance rates. If it's a low probability of recurrence, you're not going to have as high insurance rates. This is where you hear a 50-year flood, a 100-year flood, a 500-year flood. This is where that comes from. How frequently does it reoccur? And typically, if you're going to buy a house, you need to show that your house is not in the 100-year floodplain. That was that FEMA packet that I showed you in class when we first started talking about streams. If you can show that your house is not in the 100-year floodplain, then you will not be required to buy flood insurance, and you'll save yourself a lot of money. You'll incur a little risk because a 500-year flood could happen. But that's what those are used for. Okay, so good you get chance. Now in this last part, you're going to use this chart again, and you're going to, it gives you some parameters here. It talks about a 100-year flood, so a recurrence interval of 100 years. Down here, you're going to bring that up to your line, and you're going to bring it across and determine what stage that was. How high did the river flood to or reach at that in that year, and then you're going to go to hopefully this map of Jordan, Minnesota, and you will add what a stage was in that 100-year flood to 690 feet, the height of this area above sea level. Okay, and using that information, then you'll have a number. So stage plus 690, that'll give you a number, and whatever elevation that is, you take a color pencil or some way, a marker, a highlighter or something, and you mark the contour line that is at that elevation that you have calculated. You'll mark it on both sides of the floodplain. So if you look here, here's Jordan. This is kind of up on the hills out of the floodplain. You go down onto the floodplain. The Minnesota River was much larger when there was glacial meltwater. That's what formed most of it. Now it exists in just a part of that floodplain. But then you go up on the bluffs on the other side of it as well. So you're going to delineate where in this river valley a 100-year flood would flood. What would it inundate? What would it put underwater? Okay, and of course, in a 100-year flood, if you wanted to build right on the edge of the river because you thought it was pretty, you're going to pay a lot of flood insurance. Okay, so that's those three elements, and good luck.